Hello, everybody. Oh, sorry. For this one, we're going to focus on a little bit of the phenomenon where water striders walk on water and how do they do that. Now, when I asked this question to all my students in class, a lot of them were talking about the bonding between the molecules and things like that, and all that was good. And some of them said it's the surface tension, which is true. So there's a surface tension in water. You put water on a table and it starts to bubble up. It's because the water molecules aren't just sticking to the table, they're also sticking to the other water molecules. And so as the water molecules stick to each other and the weight from the water strider is spread out, it can walk on the water because of the surface tension. Now, I even pointed out that even us as humans, we can float on water for a little bit, but because of the surface tension, it'll hold our weight for a little bit of time, but we are more dense than the water, so we tend to start sinking. Now, water sticking to water molecules sticking to other water molecules is actually called cohesion. Cohesion is water molecules sticking to water. As we talked about before, because of the slight positive charge and negative charges of the oxygen and hydrogen, the water molecules are actually slightly attracted to each other, and so they actually will stick together, and we call that cohesion. And so you get this pretty cool little phenomenon where you get water that actually sticks to each other. It's pretty awesome. So just knowing this just blows my mind that we know this. So the next thing is adhesion. Adhesion is pretty much any other type of molecule sticking to another type of molecule. So for my class's purposes, I like to say water sticking to other things. So paper towels, water sticking to a paper towel, water sticking to just whatever, your skin, whatever, the desk, anything like that. That is adhesion. Kind of like this adhesive for a fingernail. Your fingernail actually sticks down because of the adhesion that's going on between the different molecules in your skin. So pretty cool. Now, here we'll just talk about this little assignment. So this assignment, you're going to drag and drop the water molecules based on how you're going to show cohesion. So drag and drop, put the water molecules together, or put the water molecules on the finger or the window, and then drag and drop the labels where they need to go. All right. Now we need to talk a little bit about solutions, solutes, and solvents. So solute is like a sugar, salt, or anything that dissolves in the solvent, which is usually water. Water is the universal solvent. So solute's usually sugar or salt, okay, that we're talking about. And a solvent is usually water. And it's anything that dissolves a solute, and then a solution is the two combined. Solution is the two combined. So let's look at our next little assignment. I want you to show me that you know what a solution, a solvent, and a solute is. So you drag and drop these labels where you think they go, and that's it. All right, now we got to talk a little bit about chemical reactions, like this truck. This truck is really rusty. It's actually formed iron oxide, which takes a while to do. Oxygen is combining with the iron and giving it this red hue. That's actually why rocks are red too. They get a little iron oxide in there. Okay. I show you this video usually with Bill Nye and talk about the different chemical reactions, but I don't want to. You guys can watch that on your own. Okay. Now, chemical equations. We need to know how to just recognize chemical equations. What's the reactants? What's the products? So as we go through, notice whichever side the arrow is pointing to, that's usually the product, and on the other side is the reactant. So if I said something like sodium reacts with chlorine and forms sodium chloride, you should know that sodium and chlorine are the reactants and sodium chloride is the product, I guess. So here's an equation you guys will see a bunch this year. So you got sugar plus oxygen makes carbon dioxide and water. So sugar and oxygen are the reactants, and carbon dioxide and water are the products. If you flip this around, it's actually the opposite. Water and carbon dioxide make sugar and oxygen. This would be the reactants, that would be the products if you flip the arrow around. This is the chemical equation for what happens when you eat sugar, eat food. Cellular respiration, you flip it around, that's photosynthesis. So you'll see that reaction quite a bit. All right, and that's it.